Okay, as you go to the review, you start on page 28. Everyone sees at the top of the page, those are textbook questions I'm recommending. Some of those have auxiliary lines on them, and there's pretty good questions here. So whether you do them today or at home, you might want to take a look at them. And then there's only, what did I give you here? Not many practice questions in the packet. And all the answers are at the end like usual. Same setup, textbook questions, packet questions, all the answers are in the back of the packet. Go to number 6, please, in your packet. We're going to go over number 6 first. I'll let you guys read it over, get a minute to process. This is like a slope type question that there's going to be 6 out of 17 tomorrow. All right, what's the symbol I gave you in between QR and ST? Perpendicular. So perpendicular, and I'm dealing with slopes. Put those two together. What do I know about those two lines and their slopes then? They are negative reciprocals of each other. Correct. They're not equal to each other. They're negative reciprocals. So if I take the slope of QR, which is x minus 1 over 4, why is this incorrect? Equals 8/3. That's an incorrect equation to solve. Why? What do we know about the two lines? Perpendicular. Maybe if I replace perpendicular with what, this would be true? Parallel, correct. All right, so you told me negative reciprocals. So I need to take one of these two fractions, flip it, and change the sign. I don't know about you guys, but I prefer to do that to one of those fractions and not the other. So instead of 8/3, replace it with what? Flip it and change the sign, negative 3/8. Are we okay on why I'm replacing it with negative 3/8 and not keeping it 8/3? Now, could you have flipped and changed the sign on x minus 1 over 4? Yeah, my confidence level is not as high as those if I did it to 8/3. How do you solve it now? How do we solve this? Got to get x by itself. Cross, multiply. Here you go. Ready? 4 times negative 3 is negative 12 equals. What do you got to do with this 8 when you cross multiply it with x minus 1? Distribute it. You can do it now. You can write it and then distribute. 8x minus 8. And then here we go. Do your algebra. Add 8. Add 8. Negative 4 equals 8x. X equals what? Negative 1/2. There you go. Again, I replace that perpendicular sign with parallel. Yes, it would be equal to 8/3 instead. All good? And of course, I do want to do a proof with you, just because we didn't have the best success on the test with that. So go to number 1. Let's go to number 1. I'll give you guys a minute or two, set it up, mark your diagram, whatever you need to do. Can we please use the givens this time? There's a reason they're telling you these lines are perpendicular. All right, let's talk. I need to prove those two lines. By the way, I know this is the first time we've seen this. When I say 1 and 2, this is a continuous proof. It's not two separate proofs. We're going to prove BF parallel to CE, continue on in the proof, and get those two angles congruent. But let's focus on the parallel lines. How do I get BF and CE? Your first job is to pick two angles that contain BF, CE, and a common transversal and try to get them congruent. We need to identify those angles right now, though, before we start. Where are those angles going to be that we're going to try to get congruent to each other? That have BF on them, that have CE, and have a common transversal. Think you got some, Bridger?
CEF and GFA.
CEF
And BFA.
Okay, I'm just here you go. CEF, I agree, that contains CE, and then BF, this is A out here, right? BFA, yeah. Is everyone all right with those two? Because are they on BF and CE? Yes. Do they share a common transversal? Yeah, right there. So those are two good angles. Let's try to do it. I'll write it down up here. We want angle BFA congruent to angle CEF. Yep. Now, are those the only two? No. Those aren't the only two we could have used. There's others out there that you could have proven congruent. All right, I need everybody to stop. I'm going to write down an incorrect statement in number 2, and you tell me why it's incorrect. All right, because this was very common on the quiz. Oh, BFA, CEF, they are congruent. Parallel lines imply corresponding angles congruent. That was easy. I'm done. Why is that not true? I need these and I don't have them. You're trying to prove them. So you need to get this right here some other way. And darn it, what did I not even touch yet? What did I not even look at and use? The givens. Look at, I just wrote that number 2, didn't even care that the lines were perpendicular. You know you're wrong. You didn't even tell me anything about the perpendicular lines. You did not even look at the givens. You got to use them. So why did they tell me those lines were perpendicular? What do they want me to put at BFA and CED or CEF? Yeah, darn right. That's why they gave it to me, to tell you that's a right angle and that's a right angle. That's why they gave it to you. And what do we know about angles that are right angles? All right angles are congruent. Not yet, though. Not step 2. Oh, it looks so beautiful in your diagram. Too bad I don't grade your diagram. What do I grade? So I better put those right angles in my statements and reasons before you tell me they're congruent. Angle BFA and angle CEF are not congruent, but they are not yet, but they're right angles first. Anybody remember the reason? Perpendicular lines form right angles. It's a 2-step process. And then in the very next step, you can tell me BFA congruent to CEF. Reason? We used to have it up on the board. All right angles congruent. That's how you get the 2 equal. That's how you get Bridger's angles congruent. Not because they're corresponding. Now, I don't know if, because this is what we did last period too. We didn't use those angles. We actually used these right here instead, the other pair next to them. You could do those too. All right, either one's acceptable. So now I have, what do I have now? I just proved those 2 angles congruent. Now the lines are parallel, BF, parallel to CE. How's this going to look when I write this? Congruent, corresponding angles, or the congruent could go at the end, implies parallel lines. All right, we got part 1 done. We have part 1 done. You ready for part 2? How do I get angle PFB congruent to QCE now? Look at them. Trace them if you have to. Here you go. PFB is that angle right there, yeah? Along with QCE. How do I get those angles equal? Do you notice anything about those angles? Parts of them are on what? The same transversal. PFCQ. Everyone agrees? And what's the other part on? The two lines we just proved parallel. So you're telling me they're on parallel lines and they have the same transversal. To me, that means they're special. They're special. What type of angles are these? Well, inside or outside the parallel lines? Okay, so it better have the word exterior. Same side or alternate sides of my transversal? You want to put the two together? All right. We don't need anything but another step now. They're already congruent. Angle PFB congruent to angle QCE. How are we starting this one off? Now, parallel lines, I just proved them. Imply, what are we calling these? We never gave a name yet. Yes, alternate exterior angles congruent. Again, they're on the parallel lines and they share a transversal. We just got to figure out what type of angles they are. Questions? I know number 3 is also prove lines parallel when you get to that one as well, just like the one on tomorrow's quiz. But so you got two options. You can keep grinding away in your packet, or you can grab a textbook and try the textbook problems out. Before tomorrow, I'd make sure we do both. But again, that's your call. I'm not checking anything. Can we use our time wisely, please, and not screw around? All right, some of you need a big shovel here, so let's get digging. All right, let's go.